A retail company stores its product catalog in tables with fixed columns for name, price, and stock quantity. They also keep customer contact details in JSON format, where some customers have multiple phone numbers and some have none. Finally, the company stores product images and marketing videos for promotional use. Which two data classifications are represented in this scenario? Select two answers. A. Structured data. B. Semi-structured data. C. Unstructured data. D. Relational metadata. E. Hierarchical data. The correct answers are A. Structured data and B. Semi-structured data. Now let's move into the explanation. Structured data is represented by the product catalog in fixed tables, because these tables have defined columns such as name, price, and stock quantity. This makes the data easy to store, query, and manage. In contrast, semi-structured data comes into play with the JSON customer details. JSON allows flexibility there, meaning some records can have multiple phone numbers, while others may not have any at all, which doesn't fit neatly into fixed columns. Moreover, while images and videos are examples of unstructured data, the question only asks for two classifications, and the focus is clearly on tables and JSON. Relational metadata and hierarchical data are not part of this scenario. Therefore, the two correct answers remain structured data and semi-structured data. A company stores customer and order information in separate tables. Each order record references a customer record through a shared ID. Which type of data storage model is being used? Select one answer. A. Flat file storage model. B. Relational model. C. Hierarchical model. D. Key value model. The correct answer is B. Relational model. Now let's go ahead and explain why. The relational model is used when data is organized into tables that can reference each other through keys. In this case, the customer table and the order table are linked using a shared ID, which is a perfect example of relational storage. By contrast, a flat file storage model would store data in single, unlinked files without any relational keys. Similarly, a hierarchical model organizes data in a tree-like structure rather than tables with shared IDs. A key value model, on the other hand, stores simple pairs of keys and values without the ability to join related data across tables. Therefore, the correct answer is the relational model, since it allows tables like customers and orders to be connected using keys. For each statement below, indicate whether the answer is true or false. Semi-structured data can store multiple instances of the same attribute for an entity. True binary files are an example of unstructured data. True semi-structured data requires every instance to have exactly the same fields. False. The first line of a CSV file may contain field names. True. Now let's explain these answers. Semi-structured formats like JSON can hold multiple values for the same attribute, such as storing several email addresses for one person. Binary files, including images or compiled programs, are unstructured because they don't have a defined schema. Meanwhile, it's incorrect to say semi-structured data must have identical fields for every record, since one record could include extra attributes while another may not. Lastly, CSV files often begin with a header row that specifies the field names, which confirms that statement as true. Which of the following is a common reason organizations store data? Select one answer. A. To delete historical information quickly. B. To record details of entities, events, and formats for later analysis. C. To ensure that all data is stored in binary format. D. To avoid analyzing the data in the future. The correct answer is B. To record details of entities, events, and formats for later analysis. Now let's go through the explanation. Organizations store data primarily so that it can be retrieved later for reporting, decision-making, and analysis. For example, sales data might be stored to track performance trends over time and to support forecasting. Deleting historical information quickly would go against the purpose of storage, since storage is meant to preserve data, not discard it. Ensuring all data is stored in binary format is not a valid reason either, because only some types of unstructured data are stored in binary. Finally, avoiding analysis in the future is also incorrect, as the main goal of storing data is precisely to enable future analysis and insight. That's why the correct answer is to record details of entities, events, and formats for later analysis. A data warehouse engineer is working with an ORC file. What does each stripe in the file contain? Select one answer. A. Only the column data for a set of rows. B. Only metadata about the file's schema. C. An index into the rows, the row data, and a footer with statistics for each column. D. Only compressed binary data with no indexing. The correct answer is C. An index into the rows, the row data, and a footer with statistics for each column. Now let's go through the explanation. ORC files are designed for efficient storage and fast queries in big data systems. Each stripe in an ORC file is divided into 3 key components. First, the row data stores the actual values. Second, the index provides a quick way to locate data without scanning the entire file. Third, the footer contains statistics for each column, such as minimum and maximum values, which further speeds up query performance. By contrast, option A leaves out indexing and the footer. Option B incorrectly describes schema metadata, which is handled at a higher level. And option D overlooks the fact that ORC supports both compression and indexing, not just raw binary storage. This is why the correct answer is the stripe structure that includes an index, the row data, and a footer with statistics for each column. Fill in the blanks by selecting the correct options from the drop-down menus. In Parquet, a row group contains one or more chunks of data, and the file's metadata describes the set of rows in each chunk, enabling quick location of the correct chunk for a given query. Now let's go through the explanation. A row group in Parquet is a logical grouping of rows that are stored together, which helps organize large datasets efficiently. Within each row group, there are smaller subdivisions called chunks, making it easier to manage and process subsets of data. The metadata in the file plays a vital role because it describes the structure, layout, and statistics of the data, which means queries don't have to scan the entire file. Instead, applications can use this metadata to quickly identify the correct chunk that matches the query conditions. This design allows Parquet to provide high-efficiency while reducing both the amount of data read from storage and the time needed to answer queries. For each database type, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Stores structured data in tables with relationships between them. Relational database. Each record has a unique identifier and a value of any format. Key value database. Stores data as JSON documents optimized for parsing and querying. Document database. Stores tabular data with columns grouped into column families. Column family database. Stores entities as nodes and defines relationships through links. Graph database. Now let's explain these matches. A relational database stores data in structured tables with defined relationships, making it the classic model for transactional systems. A key value database works differently by assigning each record a unique key paired with a value, which can be any format, enabling very fast lookups. Document databases take this concept further by storing values as documents, often in JSON format, making them ideal for flexible and semi-structured data. Column family databases, such as Cassandra, store data in tabular form, but organize columns into families, which improves performance for large-scale workloads. Finally, graph databases represent data as nodes and relationships as edges, making them powerful for scenarios like social networks where connections matter. That's how each description aligns with the correct database type. Why is SQL similar across multiple relational database systems? Select one answer. A. It is based on an ANSI standard. B. All databases use the same vendor software. C. It is only used in cloud environments. D. It is open source software. The correct answer is A. It is based on an ANSI standard. Now let's explain why. SQL is standardized by ANSI, which ensures that the language has a consistent structure across different relational database systems. This means that whether you are using SQL Server, Oracle, or MySQL, the core commands and syntax remain the same, even though vendors may add their own extensions. On the other hand, saying all databases use the same vendor software is incorrect because each vendor develops its own implementation, but they follow the standard. Similarly, SQL is not limited to cloud environments. It is used in both on-premises and cloud systems. Finally, SQL is not open source software itself, but rather a standardized query language. That's why the correct answer is that SQL is similar across systems because it is based on an ANSI standard. For each ACID property, drag it to its correct definition in the correct match column. Each item may be used once, more than once, or not at all. Each transaction is a single unit that fully succeeds or fully fails. Atomicity transactions move the database from one valid state to another. Consistency. Concurrent transactions do not interfere and result in a consistent state. Isolation. Committed transactions remain committed even after system failure. Durability. Now let's go through the explanation. Atomicity means that a transaction is indivisible. It must either complete entirely or not at all. For example, when transferring money between two bank accounts, either both the debit and credit happen or neither does. Consistency ensures that transactions move the database from one valid state to another, guaranteeing that data always follows defined rules, like maintaining balanced totals. Isolation prevents concurrent transactions from interfering with each other. For instance, if two customers try to buy the last item online, isolation ensures only one succeeds while maintaining a valid state. Durability means that once a transaction is committed, it remains saved even in the event of a system crash or power failure, protecting the integrity of stored data. Together, these four properties guarantee reliable and predictable database transactions. During a funds transfer, another transaction checks both account balances. The results show both balances either before or after the transfer, never a mix of the two. Which ACID property is ensuring this? Select one answer. A. Atomicity. B. Durability. C. Consistency. D. Isolation. The correct answer is D. Isolation. Now let's go through the explanation. Isolation ensures that other transactions cannot see partial or intermediate states while a transaction is in progress. In this scenario, when the funds are being transferred, the system guarantees that the other transaction checking balances will only see a consistent snapshot, either before the transfer starts or after it is fully complete, but never a mix in between. Atomicity is related to making sure the whole transfer succeeds or fails, not about what others can see during processing. Consistency guarantees the database moves between valid states, but here the focus is specifically on preventing mixed visibility. Durability, on the other hand, ensures changes are permanent once committed, not about controlling visibility during execution. That is why isolation is the property, ensuring that balances appear consistent during the transfer. For each statement below, indicate whether the answer is true or false. A data lakehouse merges the storage flexibility of a data lake with relational querying. True OLAP models can only store raw unaggregated data. False data warehouses typically use a relational schema optimized for read-heavy workloads. True data scientists often work with pre-aggregated OLAP cubes rather than raw data files. False. Now let's go through the explanation. A data lakehouse is indeed true because it combines scalable file storage, like a data lake, with relational querying power, making it flexible yet structured for analysis. OLAP models storing only raw data is false since they actually store pre-aggregated measures to speed up analytical queries. Data warehouses typically rely on relational schemas such as star or snowflake, which are optimized for read-heavy operations, making that statement true. Finally, the idea that data scientists mostly work with OLAP cubes is false. They usually work with raw data in a data lake, applying their own transformations and models. Fill in the blanks by selecting the correct options from the drop-down menus. Analytics can be based on a single snapshot of data at a given point in time, or on a series of snapshots. Now let's go through the explanation. A snapshot refers to a static capture of data at one specific moment, like taking a picture of sales numbers at the end of the day. This is useful when you want to analyze data at a particular point in time. On the other hand, a series of snapshots captures data across multiple points, allowing trend analysis over time, such as tracking sales performance across several weeks or months. Sequence would imply order rather than capturing states in time. Schema defines structure rather than time-based data, and warehouse describes a storage system, not point-in-time captures. That's why the correct choices here are snapshot for a single capture and series for multiple captures over time. An organization's data architecture includes a data lake, a data warehouse, and an OLAP model. Match each type of user to the stage they are most likely to work with. Select 3 answers: A. Data scientists, data lake; B. Data analysts, data warehouse; C. Business users, data lake; D. Business users OLAP model. The correct answers are A. Data scientists data lake, B. Data analysts data warehouse, and D. Business users OLAP model. Now let's explain why. Data scientists typically work with raw and often unstructured data, which makes the data lake their primary environment. They explore, clean, and model data for advanced analytics and machine learning. Data analysts, on the other hand, rely on structured and curated data, which is why they use the data warehouse to query tables and run reports. Business users generally consume insights rather than working directly with raw data. That's why they interact most with OLAP models, where dashboards and aggregated reports provide quick answers to business questions. Business users rarely access raw data in a data lake, which makes option C incorrect. This is why the three correct matches are data scientists with data lakes, data analysts with data warehouses, and business users with OLAP models. Which two responsibilities typically belong to a database administrator? Select two answers. A. Designing database backup and recovery strategies. B. Building data pipelines to transfer data between systems. C. Creating analytical models for visualizations. D. Granting or denying user access to data. The correct answers are A. Designing database backup and recovery strategies, and D. Granting or denying user access to data. Now let's go through the explanation. Database administrators are responsible for ensuring that data is protected and recoverable. That's why they design and implement backup and recovery strategies, making sure information can be restored if systems fail. They also manage security by granting or denying user access to data, controlling who can view, update, or delete sensitive information. On the other hand, building data pipelines to move information between systems is typically handled by data engineers, since it involves integration and data flow design. Similarly, creating analytical models for visualizations falls under the role of a data analyst, who focuses on interpreting data and presenting insights. Therefore, the responsibilities that belong to a database administrator are designing backup and recovery strategies and managing user access to data. Arrange the following stages in the correct order for how data typically flows through these roles. 1. Data is stored and secured in a database by a database administrator. 2. A data engineer transfers, cleanses, and transforms the data for analysis. 3. A data analyst builds models and visualizations from processed data. Now let's go through the explanation. The first step begins with the database administrator, who ensures that operational data is stored securely, properly backed up, and accessible. Once the data is secured, the data engineer steps in to transfer, cleanse, and transform it. This preparation ensures that the raw information is converted into a usable form for deeper analysis. Finally, the data analyst uses this processed data to create models, reports, and visualizations that guide business decision-making. This flow reflects the natural handoff of responsibilities, from storage and security to preparation, and finally to analysis and insight generation. Fill in the blanks by selecting the correct options from the drop-down menus. Microsoft Purview provides a solution for enterprise-wide data governance and data discoverability. Now, let's go through the explanation. Enterprise-wide data governance is about enforcing policies, rules, and controls across all data assets in an organization, and Microsoft Purview helps ensure compliance and security in this area. Data discoverability, on the other hand, focuses on making it easy to catalog, classify, and locate trusted data for analysis and reporting. This allows teams to quickly find the right data without duplication or wasted effort. By contrast, transaction processing is handled by transactional databases, not a governance tool like Purview. Low-latency data queries are better supported by systems such as Azure Cosmos DB. AI modeling is also not part of Purview, but instead carried out in platforms like Microsoft Fabric or Azure Databricks. That's why the correct options are enterprise-wide data governance and data discoverability. Which storage technology underpins Microsoft Fabric's unified data platform? Select one answer. A. Microsoft OneLake. B. Azure Data Lake Storage. C. Azure SQL Database. D. Azure Cosmos DB. The correct answer is A. Microsoft OneLake. Now let's explain why. Microsoft Fabric uses OneLake as its centralized storage foundation. All data across Fabric services is unified in OneLake, ensuring consistency and easy access for analytics and machine learning. While Azure Data Lake Storage is a related technology, Fabric specifically builds on OneLake for integration. Azure SQL Database, on the other hand, is a transactional system and not the core storage for Fabric. Similarly, Azure Cosmos DB is a NoSQL database designed for distributed applications, not Fabric's centralized storage layer. That's why the correct answer is Microsoft OneLake. Which Azure open-source relational database lets you store data in traditional relational tables and also supports custom data types? Select one answer. A. Azure Database for PostgreSQL. B. Azure Database for MariaDB. C. Azure SQL Database. D. Azure Cosmos DB. The correct answer is A. Azure Database for PostgreSQL. Now let's go through the explanation. PostgreSQL is known as an advanced open-source relational database because it not only stores data in structured relational tables, but also supports custom data types, JSON, and even non-relational properties. This flexibility makes it ideal for hybrid workloads that require both traditional relational schemas and extended functionality. MariaDB, while also open source, is more focused on performance and compatibility with MySQL without the same breadth of custom type support. Azure SQL Database is a fully relational system but does not provide hybrid object relational features. Finally, Azure Cosmos DB is a NoSQL database, so it does not fall under relational systems at all. That's why the correct answer is Azure Database for PostgreSQL. For each statement below, indicate whether the answer is true or false. The relational model replaces arbitrary, application-specific data structures with a standardized approach. True. A table in a relational database can contain rows with different column definitions. False. In a relational database, an entity can represent an object or an event. True. All columns in a table must always have a value. False. Now let's go through the explanation. The relational model is indeed true because it standardizes data using tables and columns, making it consistent across applications instead of relying on custom structures. The idea that a table can contain rows with different column definitions is false, since all rows in a relational table must share the same structure. An entity in a relational database can represent real-world objects like customers or abstract events, such as transactions, which makes that statement true. Finally, it is false that all columns must always have a value, because databases allow null values to handle missing or unknown information. Fill in the blanks by selecting the correct options from the drop-down menus. In a relational database, each row stores a single instance of an entity, while each column stores data of a specific data type. Now let's go through the explanation. A row in a relational database represents one instance of an entity. For example, in a customer table, each row corresponds to one customer with their details. A column, on the other hand, is designed to hold values of a specific data type, such as integers for age, text for names, or decimals for prices. Together, rows and columns make up the structure of a table. The term table would not be correct here because it contains multiple rows and columns, not just one instance. Keys are used for identifying or relating rows, not for storing data values. Similarly, a schema defines the structure of the database overall, but doesn't directly store individual values. That's why the correct terms are row for a single entity instance and column for data of a specific data type. For each relational database key concept, drag it to the appropriate boxes in the correct match column to match it against its definition in the option column. Uniquely identifies each instance of an entity, primary key, links one entity to a related entity, foreign key, identifies a record by a unique combination of multiple columns, composite key, enforces that a foreign key value must match an existing primary key, referential integrity. Now let's go through the explanation. A primary key is used to uniquely identify each row in a table, ensuring no two rows share the same identifier. A foreign key establishes a link between two tables by referencing the primary key of another table, enabling relationships. A composite key, by contrast, uses two or more columns together to uniquely identify a record. For example, an order number combined with an item number can uniquely identify a line item. Referential integrity enforces the rule that any foreign key value must correspond to a valid primary key, preventing invalid or orphaned relationships between tables. Unused here are surrogate keys, which are artificial identifiers created purely for uniqueness, and natural keys, which are derived from real-world data but were not part of the listed definitions. Fill in the blanks by selecting the correct options from the drop-down menus. To create an index on a column, you use the create index statement, while to execute a stored procedure, you use the exec statement. Now let's go through the explanation. Create index is used to define a new index on one or more columns in a table, which helps speed up data retrieval by allowing the database engine to quickly locate rows. Exec, on the other hand, is used to run a stored procedure along with any required parameters. Create procedure is different because it defines the stored procedure but does not execute it. Run proc is not valid SQL syntax, which makes it incorrect in this context. This is why create index is used for indexes, and exec is used for executing stored procedures. For each statement below, indicate whether the answer is true or false. Azure SQL Database offers 99.995% availability. True SQL Server on Azure virtual machines is a PaaS solution. False Elastic Pool in Azure SQL Database allows multiple databases to share resources. True Azure SQL Edge is intended for enterprise-scale data warehousing. False. Now let's go through the explanation. Azure SQL Database provides a very high availability SLA of 99.995%, which makes the first statement true. SQL Server on Azure Virtual Machines is actually an infrastructure as a service IaaS solution, not PaaS, so that statement is false. Elastic Pool is true because it enables multiple databases to share pooled compute and storage resources, making it cost-efficient. Finally, Azure SQL Edge is false in this context because it is optimized for IoT and time series data, not for large-scale enterprise data warehousing. An application frequently needs to retrieve customer and order details together for shipping purposes. The developer wants to simplify these queries by combining the data into a single reusable object. Which database object should they create? Select one answer. A. Stored procedure. B. Index. C. Constraint. D. View. The correct answer is D. View. Now let's go through the explanation. A view allows data from multiple tables to be combined into a virtual table that can be queried as if it were a single object. This makes it ideal for simplifying repeated queries, such as retrieving customer and order details together. A stored procedure, while powerful, is designed for executing programmatic actions rather than creating a reusable dataset. An index improves performance by speeding up searches, but does not combine data from tables. A constraint is used to enforce rules on data values, such as ensuring a column cannot have nulls, but it does not simplify query logic. That's why the correct choice here is a view, as it provides a reusable and simplified way to query combined data. A company wants to run part of its application on premises while hosting its database in Azure. They also require OS-level access for certain configurations. Which Azure SQL option should they use? Select one answer. A. Azure SQL Database. B. SQL Server on Azure Virtual Machine. C. Azure SQL Managed Instance. D. Azure SQL Edge. The correct answer is B. SQL Server on Azure Virtual Machines. Now let's explain why. SQL Server on Azure Virtual Machines is the best choice when OS-level access is required, because it allows administrators to configure the environment just like an on-premises SQL Server installation. It also supports hybrid scenarios where part of the workload runs locally and part in Azure. Azure SQL Database is fully managed and doesn't provide OS-level access, making it better for cloud-native applications. Azure SQL Managed Instance is also a PaaS service that simplifies management but doesn't grant full OS control. Azure SQL Edge is designed specifically for IoT and edge devices, not for hybrid enterprise workloads. That makes SQL Server on Azure Virtual Machines the correct option in this scenario. Which two Blob access tiers in Azure Blob Storage are designed for online data retrieval? Select two answers. A. Cold. B. Hot. C. Cool. D. Archive. The correct answers are B. Hot and C. Cool. Now let's move into the explanation. The hot tier is meant for data that is accessed frequently and requires minimal latency. For example, active files or transaction logs that applications use regularly. In contrast, the cool tier is designed for infrequently accessed data, but is still available online with low latency, which makes it useful for backups or data you don't need often, but still want quick access to when required. On the other hand, the archive tier stores data offline and requires rehydration before it can be retrieved, so it is not suitable for online access. Finally, cold is not an official Azure Blob tier, so it is not a valid option. Consequently, the correct choices for online retrieval are hot and cool. Fill in the blanks by selecting the correct options from the drop-down menus. The hot tier is the default for frequently accessed blob data, while the archive tier is intended for rarely accessed, historical data with the lowest storage cost. Now let's move on to the explanation. The hot tier is the default option because it is designed for frequently accessed data stored on high-performance media that ensures minimal latency. For example, an e-commerce website storing daily product images would benefit from the hot tier. On the other hand, the archive tier is meant for data that is rarely accessed, but needs to be preserved at the lowest possible cost, such as compliance documents or historical transaction records. Meanwhile, the cool tier, though useful for infrequent access, still offers online availability and therefore does not represent the lowest cost option. Finally, Premium is not an access tier in Azure Blob Storage, which makes it incorrect. Consequently, the correct choices are Hot for frequently accessed data and Archive for rarely accessed historical data. For each statement below, indicate whether the answer is true or false. Azure Blob Storage virtual folders allow bulk operations such as moving and deleting blobs. False. The archive tier may require hours for data retrieval due to rehydration. True, lifecycle policies in Azure can delete outdated blobs after a specified number of days since last modification. True, relational databases store data in related tables and are managed using SQL. True now. Let's move into the explanation. Virtual folders in Azure Blob Storage are not actual folders, but only naming conventions that use forward slashes, so they don't support true folder-level operations, which makes the first statement false. On the other hand, the archive tier keeps data offline, and retrieving that data requires a process called rehydration that can take several hours, making the second statement true. Additionally, lifecycle management in Azure can be configured to automatically delete or transition blobs after a defined period of inactivity, which supports the third statement as true. Finally, relational databases are designed to store data in structured, related tables, and they are managed using SQL, confirming the last statement as true. Match each OneLake concept with the correct fixed description. Automatically provisioned for every Microsoft Fabric tenant is OneLake, stores data in Delta Parquet format and supports ADLS Gen 2 APIs, is open and compatible, enables distributed data ownership within workspaces, is distributed ownership and collaboration, serves as a single, organization-wide data lake, is OneLake, allows navigating data from Windows using a file explorer, is easy to navigate. Now let's explain. OneLake is automatically provisioned for every Microsoft Fabric tenant, ensuring that every organization has a unified data lake by default. Moreover, it also serves as the single organization-wide data lake, providing a central point for data storage. Next, open and compatible refers to its ability to use ADLS Gen 2 APIs and Delta Parquet format, which makes it interoperable with existing tools and frameworks. Additionally, distributed ownership and collaboration means that different workspaces within the organization can manage their own data independently while still following governance rules. Finally, easy to navigate highlights how OneLake integrates with Windows through the OneLake File Explorer, making it simple for users to browse and access data directly from their desktops, much like navigating local folders. For each statement below, indicate whether the answer is true or false. On-premises file shares typically work well for computers on the same local network is true. On-premises file shares scale easily for global access without additional infrastructure is false. Hosting file shares in Azure removes the need for maintaining physical hardware is true. In Azure Files, all file data in a storage account must be contained within a single file share is false. Now let's explain. On-premises file shares are indeed effective for local environments because LAN-based systems work best when computers are on the same network. However, they do not scale well globally without extra solutions like VPNs or third-party tools, which is why the second statement is false. Furthermore, hosting file shares in Azure eliminates the burden of maintaining physical servers since the infrastructure is managed in the cloud, making the third statement true. Finally, Azure Files allows data in a storage account to be spread across multiple file shares, not restricted to just one, which makes the last statement false. Select one answer. A developer is building an application that stores varying numbers of addresses and phone numbers per customer in a single row. The app needs fast point queries and range queries within related groups of data. Which Azure service feature best supports these requirements? A. Azure Blob Storage with hot tier. B. Azure SQL database with foreign keys. C. Azure Table Storage with partitioning and composite keys. D. Azure File Storage with NFS. The correct answer is C. Azure Table Storage with partitioning and composite keys. Now let's explain. Azure Table Storage with partitioning and composite keys is the best choice because it supports semi-structured data stored in single rows and enables fast point and range queries within partitions. For instance, if a customer has multiple addresses or phone numbers, the data can all be grouped efficiently under one partition, making queries much faster. In contrast, Azure Blob Storage with hot tier is optimized for unstructured objects like images or backups, but not for running queries on table data. Likewise, Azure SQL database with foreign keys is excellent for relational models, but it distributes data across related tables, making it less efficient for this specific scenario. Lastly, Azure File Storage with NFS is designed for network file shares, not for querying semi-structured datasets. Therefore, the most effective solution is Azure Table Storage with partitioning and composite keys. Which two statements are true about Azure Table Storage data structure? Select two answers. A. All rows in a table must have identical columns. B. Each row must have a unique key composed of partition key and row key. C. Columns in each row can vary. D. Azure Table Storage enforces foreign key relationships. The correct answers are B. Each row must have a unique key composed of partition key and row key, and C. Columns in each row can vary. Now let's explain these answers. Azure Table Storage requires each row to be uniquely identified, and this is achieved through a composite key made up of the partition key and the row key. This ensures that no two rows are the same, even within the same partition. Additionally, columns in each row can vary, which makes table storage highly flexible for semi-structured data, as not all rows need to follow an identical schema. On the other hand, it is not required for all rows to have identical columns. Unlike relational databases, and foreign key relationships are not enforced since table storage is designed for NoSQL scenarios without relational constraints. Arrange the following steps in the correct sequence for how Azure Table Storage processes a query that returns a single row. Identify the partition using the partition key. Locate the row within the partition using the row key. Return the matching row to the application. Now let's explain. The process begins with identifying the partition using the partition key, which narrows the search down to the correct group of rows. After that, the row is located within that partition by using the row key, ensuring a unique and efficient lookup. Finally, once the row is found, the matching result is returned back to the application. This order is fixed because Azure Table Storage first needs to know the partition, then the row, before it can deliver the result. For example, imagine you are searching for a customer's address. You first go to the correct folder, labeled with the customer group, then find the exact file by name, and finally hand that file back to the person who requested it. That's exactly how Azure Table Storage processes queries. For each Azure Cosmos DB API, drag it to match its associated data model or structure. Each item may be used once, more than once, or not at all. Cosmos DB for NoSQL, document data model JSON. Cosmos DB for MongoDB, BSON document model. Cosmos DB for PostgreSQL, relational table model. Cosmos DB for table, key value table model. Cosmos DB for Apache Cassandra, column family model. Cosmos DB for Apache Gremlin, graph model. Now let's explain these matches. Cosmos DB for NoSQL uses a document data model based on JSON, which allows flexible storage and querying of semi-structured data. In contrast, Cosmos DB for MongoDB adopts the BSON document model, staying compatible with MongoDB drivers and applications. Similarly, Cosmos DB for PostgreSQL follows the relational table model, providing structured tables and SQL queries. Moreover, Cosmos DB for Table applies the key-value table model, enabling fast lookups through partition and row keys. Additionally, Cosmos DB for Apache Cassandra uses the column family model, where rows can have varying numbers of columns, ideal for high-volume workloads. Finally, Cosmos DB for Apache Gremlin uses the graph model, representing entities as vertices and their relationships as edges, which is especially useful in social networks or recommendation systems. A retail company wants to migrate its e-commerce platform's database to Azure while continuing to use MongoDB client libraries and BSON data format without rewriting its application code. Which Azure Cosmos DB API should they choose? A. Cosmos DB for NoSQL, B. Cosmos DB for MongoDB, C. Cosmos DB for Apache Cassandra, D. Cosmos DB for Table. The correct answer is B. Cosmos DB for MongoDB. Now let's explain. Cosmos DB for MongoDB is the right choice because it supports MongoDB client libraries and BSON document storage, meaning the company can migrate without rewriting its existing application code. On the other hand, Cosmos DB for NoSQL is built for JSON documents and SQL syntax, which would not be compatible with BSON or MongoDB drivers. Similarly, Cosmos DB for Apache Cassandra uses a column family model, making it unsuitable for BSON storage. Finally, Cosmos DB for Table is based on key-value pairs and does not support BSON either. Therefore, Cosmos DB for MongoDB ensures a seamless migration path while maintaining compatibility with the company's current tools and formats. Fill in the blanks by selecting the correct options from the drop-down menus. Cosmos DB for Apache Gremlin stores data in a graph structure, where entities are represented as vertices and relationships as edges. Now let's explain. Gremlin is specifically designed for graph-based data, which means it models information as interconnected entities. Entities such as users, products, or devices are represented as vertices, while the relationships between them, like a user purchasing a product or a device connecting to another, are expressed as edges. This model makes it powerful for scenarios like social networks, fraud detection, and recommendation engines, where connections matter as much as the data itself. Unlike relational tables or columns, which store data in a flat and structured format, graphs provide a natural way to represent and query complex relationships efficiently. That's why in Gremlin, we talk about vertices and edges rather than tables and rows. Match each description to its correct processing method or characteristic. Each item may be used once, more than once, or not at all. Processes multiple records together after collection. Batch processing. Processes each record immediately as it arrives. Stream processing can process all data in the dataset. Data scope in batch processing, typically limited to most recent data or rolling window. Data scope in stream processing. Now let's explain these matches. Batch processing handles data in bulk after it's collected, which makes it useful for tasks like end-of-day financial reconciliations. Stream processing, on the other hand, reacts instantly to incoming data, which is why it's great for things like fraud detection and banking. Batch processing also allows the system to analyze the entire dataset at once, giving businesses insights across historical data. In contrast, stream processing usually looks only at the most recent or time-windowed data, such as monitoring live sensor feeds from IoT devices. Together, these two methods balance deep historical analysis with real-time responsiveness. Fill in the blanks by selecting the correct options from the drop-down menus. Lambda and Delta architectures are design patterns that combine batch and stream processing in a single analytical solution. Now let's explain these matches. Lambda architecture is a design approach that integrates large-scale batch processing with real-time streams, making it useful for scenarios like fraud detection, where historical and real-time insights are needed together. Delta architecture, on the other hand, simplifies this by unifying batch and streaming into one consistent model, reducing complexity. Both rely on batch and stream processing, meaning they can handle large historical datasets while also reacting instantly to live data. For instance, an e-commerce platform could use Delta architecture to analyze years of sales data while also tracking current customer activity in real time. This combination ensures both depth of insight and immediacy of response. Fill in the blanks by selecting the correct options from the drop-down menus. After processing, a stream can be written back into Azure Event Hubs as a queue for downstream processing before being stored in Azure SQL Database or other analytical tables. Now let's explain these matches. Azure Event Hubs acts as a sink, meaning it queues processed data so it can be consumed again for further downstream analytics or transformations. Downstream processing refers to any additional steps applied to the data after the initial stream, such as enrichment or aggregation. Once processed, the results are often written into Azure SQL Database, which provides a structured format for querying and analysis. For example, a financial services company might stream transactions through Event Hubs, apply fraud detection rules in real time, and then store flagged transactions in Azure SQL Database for investigators to review later. This flow ensures both continuous processing and reliable storage for analytics. For each statement below, indicate whether the answer is true or false. Batch processing is ideal for time-critical operations. False. Stream processing has latency measured in seconds or milliseconds. True, errors in batch jobs can halt the entire processing run. True, stream processing can process all data in a dataset at once. False. Now let's explain these answers. Batch processing is not suited for time-critical needs because it runs on collected data at scheduled times, making it better for large-scale but non-urgent workloads. On the other hand, stream processing provides near real-time results with latency in seconds or even milliseconds, which is why it's used for scenarios like fraud detection or live dashboards. Furthermore, errors in batch jobs can indeed halt the whole process, since the workflow depends on completing all tasks successfully before results are delivered. However, stream processing does not work on full datasets at once. Instead, it operates on continuous flows of data in smaller windows, ensuring immediate insights rather than complete dataset analysis.